With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, here's our question. An AC source of frequency omega, when fed into a RC series circuit, current is recorded to be I. Okay, that means when frequency is omega, the current across RC circuit is I. If now the frequency is changed to omega by 4, keeping voltage same, now the frequency becomes omega by 4, then the current is found to be I by 2, then current becomes I by 2. The ratio of the reactant to resistance at original frequency omega is. Okay, so we have to find the ratio of reactance, so that is here only capacitor is present because we have RC circuit. So XC divided by the resistance. Okay, so we have to find the value of XC upon R when the frequency is omega. In the circuit, we have only resistance and one capacitor. Okay, and this is the voltage source. Let us take the voltage of this source is equals to V. The resistance here is R and capacitance is C. Okay, so initially when the frequency is omega, the current is I. The value of current is given by I equals to V upon Z. Here Z is the impedance. Okay, so we have to find the impedance first. So impedance is given by under root of R square plus XC square. Okay, and XC is given by 1 upon omega into C. So we can put this value of XC here. So we have Z equals to under root of R square plus 1 upon omega square into C square. Okay, this is the value of Z. Let us take it to be Z1 because it is the value when frequency is omega. Now, in second case, when the frequency becomes omega by 4, then Zc will be equals to 1 upon omega by 4 into C. That is 4 upon omega C. Okay, now put this value here. So we have R square plus Xc square, that is 4 square divided by omega square into C square. Now we can simplify this Z1 and Z2. So Z1 will be written as under root of R omega C whole square plus 1 upon omega C, and Z2 can be written as under root of R omega C whole square plus 16 divided by omega into C. So now let us write the current in the two cases. So in first case current is I, which is given by voltage upon impedance. Okay, so impedance is Z1, so it will be under root of R omega C whole square plus 1. Okay, and divided by omega C. And in second case the current is I by 2. It will be equals to voltage is same in both the cases, so we have written V divided by Z2. Z2 here is R omega C square plus 16 divided by omega C. Here we can write I upon V is equals to omega C upon under root of R omega C square plus 1. Okay, and here we can write I upon V. This 2 will multiply here, so it will be 2 omega C divided by under root of R omega C square plus 16. Okay, now these two quantities are equal, so we can equate these two. So we have omega into C divided by under root of omega C square plus 1 is equals to 2 omega C divided by under root of R omega C square plus 16. Okay, here omega C and omega C will get cancelled out and we will cross multiply this and square. Okay, so now on cross multiplying and squaring both sides, we have r omega c whole square plus 16 is equals to 4 times of r omega c whole square plus 4. Okay, because the square of 2 will become 4 and it will multiply it with both these terms. So now simplify it. So we have 16 minus 4 is equals to 4 r omega c square minus r omega c square. So it will become 12 and here it will become 3 into r omega c square. Okay, so we have r omega c square is equals to 4 and on taking root we have r omega c is equals to 2. Okay, so from this we can write omega c is equals to 2 upon r. Now in question it is given that we have to find xc upon r. So the value of xc is given by 1 upon omega c divided by r. Okay, and the value of omega into c we have just calculated, it is equals to 1 divided by the value of omega c is equals to 2 upon r. So r will come in numerator divided by r. Okay, so on finally solving this, here 2r and r will get cancelled out and finally we will get this ratio as 1 upon 2. Okay, so here option B is 1 upon 2. So option B is the right answer for this question. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.